Give me 7 minutes and 7 facts, then give yourself 7 days to argue less and no more. If this doesn't lighten next week's debates about Pluto by day 7, discard the method. Tonight you'll get numbers, procedures, and one quiet way to measure your own clarity. By next weekend, count how many conversations gently shift from heat to light. For the next 7 days, replace adjectives about Pluto with figures, dates, and trade-offs. We tightened our language in 2006 because taxonomy follows dynamics. A planet orbits the Sun, is round under its gravity, and has cleared its orbital neighborhood of comparably massive bodies, IAU 2006. Pluto aces the first 2 and fails the third because it swims with peers in the Kuiper Belt. That is not an insult, it's a map. Call it Dwarf Planet. Call it Kuiper Belt Primary. The label is a user interface for predictions, not a mood ring. Count first. A shy student feels her cheeks burn when classmates roll their eyes at Pluto talk. She goes home, copies 3 criteria on a sticky note, and returns with a diagram of resonances and a sentence about neighborhood clearing. The room quiets the way numbers quiet a crowd. New Horizons launched January 19, 2006, on an Atlas V5521 with a Star 48 kickstage, a 478-kilogram spacecraft carrying LORRI, Ralph, Alice, Rex, and dust counters, NASA 2015. It crossed lunar distance in 9 hours, reached Jupiter in 13 months for a gravity assist, and hit its Pluto flyby on July 14, 2015, with minutes of timing margin. 1 pass, no second chance, a downlink measured in kilobits per second. Engineers rehearsed until boredom felt like safety. Write the 3 IAU criteria on a card and test Pluto honestly. The first resolved views overturned the snowball cliché. Tombaugh Regio's bright heart and its left lobe, Sputnik Planitia, presented a nitrogen ice basin, roughly Texas-sized, astonishingly young by crater counts, GUAPL 2016. Polygonal convection cells tiled the plane, slow motion made visible by geometry, heat rising from depth, surface frost sublimating to gas, then refreezing downwind. Around the margins, blue-white flows trace glaciers pouring from water-ice highlands into the basin, guided by winds and gentle slopes. No hype here. Numbers sharpen the picture. Pluto's mean radius is about 188 kilometers. Mass 1.31 x 10, 22 kilograms. Density 1.86 g/3. Surface gravity 0.62 m/s2. Its geometric albedo is high, so it looked bigger than it is when merely a point. The orbit is elliptical and inclined 17 degrees in 3.2 resonance with Neptune that prevents close meetings. A year lasts 248 Earth years, a day 6.4. None of that cares about sentiment. All of it predicts seasons, haze, frost, and the stubborn patience exploration must obey. Sketch Pluto's elongated, tilted orbit and mark resonance instead of luck. Binary dynamics add strangeness with purpose. Charon is half Pluto's size. The pair are tightly locked around a barycenter outside Pluto's surface, so one hemisphere always faces the other. Stand on the far side and you will never see Charon. Stand on the near side and it never moves. This configuration strongly hints at a formative impact, an energy source that stirred interiors, fractured crust, and left the mass anomaly that later reoriented the world, so Sputnik Planitia migrated toward the tidal axis. The basin likely acts as a cold trap for volatiles, its bright surface reflecting light, its depth and latitude managing frost, and its position opposite Charon linking tides to climate. Surface chemistry keeps the palate honest. Tholins, radiation-forged organics, redden stretches like Thulumacula. Nitrogen, methane, and carbon monoxide frost brighten others. Haze layers stack dozens deep, thin but structured, a sky woven from particles born of sunlight cracking simple molecules, then clumping and falling like slow, reddish snow. Pressure near the surface hovers near microbar levels and varies with season. The winds are gentle. The cycles are real. A tenuous sky can still do work when gravity is low, and frost migrates with every sunrise. Haze layers climb hundreds of kilometers, then settle, Pressure shifts with season as nitrogen trades places between ground and air. Charon shows no comparable atmosphere, but its north sight's dark with tholins, likely baked from methane captured and processed from Pluto's slow outbreaths. List 5 mission constraints and tie each to hardware, software, or pacing. Then the mountains. Water ice massifs rise like crumpled granite, where nitrogen erodes around harder skeletons. South and west, broad shield-like mounds, Wright Mons and Picard Mons, suggest cryovolcanism. They erupt slurries of water, methane, perhaps ammonia, resurfacing without many craters, hinting at geologically recent activity, Science 2016. At Pluto temperatures, water ice is bedrock, nitrogen is snow, ammonia makes brine flow. You do not need lava to build a volcano when chemistry grants you a low-temperature engine. Still more questions. Ask why a flyby, not an orbiter. The answer is trade-offs. To capture at Pluto from a fast heliocentric trajectory demands double-digit kilometers per second of DV or decades of aerobraking that Pluto cannot offer, plus long cruise RTG power and deep space network time that would crowd other missions. A flyby makes one promise: arrive, measure, leave, and keeps it by ruthless prioritization. That choice maximized science per kilogram and per year when the budget, sun angle, and patience met in a narrow window. Risk was tamed by procedure more than heroics. Commands were time-tagged months in advance. Autonomous fault protection favored data over gambles. Redundant recorders soaked up bursts. DSN 70-meter windows were booked weeks ahead. Targets were tiered as must-get and like-to-get. Recovery trees for safe mode were rehearsed until muscle memory replaced suspense. One pass forbids improvisation. Mitigation is disciplined boredom, simulations, checklists, and a bias to the simplest working plan that survives distance, latency, and boredom. Stand up, breathe, and draft one mitigation plan before your next ambitious task. Classifications are tools, not verdicts. The cleared neighborhood clause is really a proxy for gravitational authority, which tracks mass and local population. Inside, it sorts the mess of asteroids from worlds. Outside, it reminds you that the Kuiper Belt is a city, not a cul-de-sac. Call Pluto what you like so long as the name preserves the power to predict convection and nitrogen ice, the persistence of a microbar sky, and the chance of an ocean insulated by salts beneath a fractured shell. Count the microbar sky and the million-year clocks, then speak more softly. Details make the case for an interior still warm. Sputnik Planitia may be a positive gravity anomaly despite being a basin, consistent with denser water beneath supporting thinner ice above. True polar wander would then reorient the whole world, putting that heavy spot near the tidal axis where energy exchange is minimized. Cryovolcanic mounds lacking craters argue for refresh. Fractures and faults imply stress. Chemistry supplies antifreeze. Radiogenic decay keeps the pilot light burning when tides have gone quiet. Noise tests discipline. A graduate student resists the comfort of a conspiratorial video about Pluto's secret ocean, puts the phone in another room, and reads instrument papers instead. She learns why stacked haze layers do not imply thick air, how sublimation curates frost, and where uncertainty bars live. In the morning, she can explain what microbar means without reaching for metaphors that outshine the data. Her confidence rises the quiet way, by counting, comparing, and revising. A boundary matters too. A friend who thrives on outrage keeps forwarding petitions about Pluto's unfair exile and demands agreement. You decide your energy is finite. You sketch the resonance web, offer to talk dynamics, and decline the outrage. The friendship survives because you set a condition. Bring questions, bring patience, or bring silence. No more heat without light. We can hold a quiet inventory. Mean surface temperature near 40-60 Kelvin. Nitrogen glaciers that creep centimeters per day when slopes permit. Winds that move haze grains like soft confetti. A day of 6.4 Earth days that sets the rhythm for frost migration. Gravity gentle enough that a baseball tossed hard would fly 40 meters high. Escape speed low enough to make volatile loss a constant tax. Each number does what poetry promises. It returns your attention to what is actually there. New Horizons was lean by design. LORRI, a narrow-angle imager, delivered sub-kilometer pixels at closest approach. Ralph combined color imaging, MVIC, with infrared spectroscopy, LEISA, to map volatile gases. Alice, a UV spectrograph, watched the sun slip behind Pluto to read the air in silhouette. And Rex bent radio waves to infer temperature and pressure. Power came from a plutonium-238 RTG, outputting a few hundred watts. Sunlight was too thin to help. Data trickled home for more than a year through 34-meter and 70-meter DSN antennas at kilobits per second. Patience and scheduling were as important as propellant. Spacecraft craftwork mattered. For most of the crews, New Horizons slept in electronic hibernation to save wear, waking for health checks, trajectory correction burns, and instrument calibrations. Hydrazine thrusters handled attitude control. Star trackers and gyros kept pointing tight. Heaters managed a thermal regime where deep cold and internal warmth must coexist. Approach imaging built an optical navigation loop that shaved uncertainties until the flyby corridor looked like a thread you could walk. Occultations turned Pluto into a laboratory. As the Sun and Earth rose and set behind the limb, Alice and Rex read refraction and absorption to stitch a layered atmosphere with haze reaching hundreds of kilometers. Ultraviolet spectra tagged nitrogen and methane. Infrared maps from Ralph's LEISA traced nitrogen, methane, and carbon monoxide across plains and mountains. Combine those with LORRI's crisp silhouettes and you get a working cycle. Frost migrates, haze forms and falls, and glaciers creep where slopes and temperatures allow. That cycle is slow to the eye but quick on geological scales, fast enough to erase craters and paint a heart that looks fresh in a place built for ancient scars. Past Pluto, New Horizons pressed onto Arrokoth on January 1st, 2019, photographing a contact binary shaped like a flattened snowman. Its gentle join and layered structure suggested slow, local accretion rather than violent shattering, a small body counterpoint to grand collision myths. That visit closed a loop. The same disciplined boredom, checklists, time tags, DSN windows, can thread needles again when a spacecraft is healthy. A trajectory is clean, and a team knows how to remove drama. The same playbook will age well wherever patience pays the bills. Pick tight objectives, time tag everything, and let discipline harvest surprise. Debates about labels will continue as they should, but the use test remains brutal. Does the category help you guess what to measure next? With Pluto, the Dwarf tag aligns with a crowded, dynamical neighborhood, volatile-driven geology, and the likelihood of oceans sustained by internal heat and salts rather than tidal needing. It anchors expectations for atmosphere, haze, and resurfacing, and it keeps honest company with Ceres, Eris, Haumea, and Makemake, each a particular answer to similar conditions. Logistics win futures. Let's end where engineers begin. Logistics. Distance dictates latency. Latency dictates autonomy. Autonomy dictates rehearsal. Power comes from an RTG, not solar panels. That fixes mass, thermal budgets, and end-of-life margins. Communication piggybacks on DSN availability between larger commitments. That sets cadence for data return. Timeline is a geometry problem with one solution. Miss it and you wait years. None of this makes headlines. All of it makes knowledge. Rockets win applause. Schedules and cadence close the gap. The downlink after Pluto took more than a year. No one hurried the speed of light, they scheduled it. List 3 constraints before you name a single aspiration this week. Now, take it outside. Find bright Jupiter, then trace the ecliptic into the dark, where a small, cold world loops unseen. Whisper its period, inclination, resonance, radius, gravity, and the pressure of its sky. Picture a heart of nitrogen cells overturning slowly like breath under ice. Imagine volcanoes that ooze slush, not fire, and basins that drift toward balance as worlds turn to face their partners. Feel how numbers hush the mind without dimming wonder, and how patience makes distant places legible. For the next week, speak in numbers first and let wonder follow.